Unit 1 is exponents, and in lesson 1.1 we're going to learn about the product, quotient, and power rules of exponents. So first we have the product. Product means you're multiplying exponents. This would be like having x squared times x cubed. If I were to write this out, x squared really means x times itself 2 times, and then times 3 more x's. So then if I want to go ahead and put that back together, that has a base of x and 1, 2, 3, 4, 5 x's getting multiplied together. So in an exponent you have what's called the base, and then it's raised to a power. So we didn't multiply 2 times 3, we actually added the powers to get 5. And that's what the rule says here. So let's try it with some harder problems. We're fully simplifying. We're going to only use positive exponents, which really won't apply here, but it'll apply when we get to the quotient rule. So you want to think about this is called a monomial, meaning it's all one term put together with multiplication. And then that's times, because it's touching in parentheses, 2x cubed y cubed. That's a monomial. You want to multiply your coefficients. 5 times 2 is 10. And then we're doing x to the 4th times x cubed. So think about how many x's would be written out. That's x times itself 4 times another 3 times. You're really adding that to get x to the 7th. Same thing with the y's. You're taking y to the 4th times y cubed. That would be 7 y's getting multiplied together. So it'd be 10 x to the 7th, y to the 7th. All right, number 2, let's try one more. I'm not going to write this one out, but this is 8 times, since there's no number or coefficient in front, that's really a -1. So 8 times -1 would be -8. This is x to the 1st. When you see no power after it, it's to the 1st. X times x cubed would be x to the 4th, because you're adding the powers. Y to the 1st times another y would be y squared. So think when you're multiplying, you're adding powers. Now let's go to quotient rule. Quotient rule means you're dividing. Okay, so think multiplying we added, dividing we're going to subtract. This would be like having x to the 5th divided by x cubed. What that means is in the numerator, 5 x's are getting multiplied together, whereas in the denominator, 3 x's are getting multiplied together. Any number divided by itself cancels to make a 1, so you would cancel pairs out, and look what you're left with, x squared. So really all you're doing is 5 minus 3 to get the 2. Okay, we also need to deal with coefficients. So 24 over 40 needs to get simplified. So you got to think about, do they divide evenly? No. Small number over a big number has to be a fraction. Then you need to divide by a common factor. I know I could divide by 4. I could divide by 8. So then my coefficients would get a 3 on top and a 5 on the bottom. That helps me set up my fraction. So I'm going to extend the bar. Now I'm going to subtract power. So this is x to the 7th over x to the 1st. You're doing 7 minus 1 to get x to the 6th. It would be in the numerator. Just think about 7x's being written out over only 1x on the bottom. Definitely more still on top. And then y to the 7th over y to the 6th. 7 minus 6 is 1. It would also be on the top. So you could see it like this, or you could write it as your 3/5 and then your x to the 6th y. But I really like it like this, and really it would look better if your 5 was in the middle. So that is your answer to number 3. All right, number 4, we have 6 over 18. 6/18 reduces to 1/3 because you're dividing by 6. X to the 4th over x to the 6th. I want you to think about what that looks like. That would be 4 x's getting multiplied on top over 6 of them on the bottom. Cancel, 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 because you're dividing a number by itself. Look where the x's are at. It gets 1 over x squared. So really what you're doing is still subtracting. I still do 6 minus 4, but since the bigger number was in the bottom, that's where the x's will still be. So 6 minus 4 is 2, but it's in the denominator. And then 7 minus 7 is 0. That is actually canceling out. So you would have everything cancel out. So your answer is 1 over 3x squared. But if you were to write this as 3x squared, that would be incorrect because 1/3 is totally different than 3 over 1. Same thing with your x squared. It has to be in the denominator. Okay, last is the power rule. Power rule is having some exponent and then it's raised to another power on the outside. That would be like having x squared raised to the third. This power of 3 means x squared is times itself 3 times. Then if I expanded that, that would be an x times another x times x times x times x. So 2, 4, 6. So what did we do with the 2 and the 3? We multiply to get the new power. And then be careful on this one. This 3 also has to get the power. Let me expand it on this one. So we're having 3x to the 5th y, that's a monomial, times itself 4 times. So this 3 times 3 times 3 times 3 has to happen. You can't just say 3 times 4 is 12. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. If you did not know that, you could use your calculator. Zoom out a little bit. And you would do your 3. And then if you want to do any power, you hit this little up arrow under the clear button. You would say 2 to the 4th power gets you 81. So this would be 81. And then you're just multiplying powers. 5 times 4 would be 20. This is a y to the first, so 1 times 4 is 4. And that would be your answer. Last but not least, we've got negative 5 to the 3rd power. So think about negative 5 times negative 5 times negative 5. It's a good thing to use parentheses around the negatives just because if you have an even power, that means there's going to be an even number of negatives getting multiplied together. That would be positive. But anytime you have a negative to an odd power, makes a negative because you're taking negative 5 times negative 5 is positive 25. 25 times another negative, negative 125. And then this is x to the first. X is not to the 3rd power. It has nothing right after it, so it's to the first. So 1 times 3 is 3. And 3 times 3 is 9. And that would be your answer.